Now, as you are familiar with the electrolysis, you are familiar with the electrode, you are familiar with the electrolyte, and even you are familiar that how the electrolysis just differ for the different molten or the aqueous electrolyte, and you know that what kind of reaction take place and how to just carry out that reactions. You are all well versed with the concept now. So there are certain laws which are actually obeyed by the electrolysis, or you can say they are actually obeyed wherever the electrolysis is taking place. So just look at those laws. So first of all, you should know that laws are given by Faraday, right? So that laws are given by Faraday. It was formulated by Faraday. So let us see what that law actually states, right? So first law just states that, as you know, that when we carry out the electrolysis, again I am repeating, as you all know that whenever we carry out the electrolysis, then what do you get? You get a substance at electrode, right? You get a pure substance always at the end of electrolysis, you get at cathode, right? So that this law actually states that what kind of or you can say what weight of substance do you get after the electrolysis, right? So this law actually states that the weight of substance, that means you get after the electrolysis, you know that whenever we carry out the electrolysis, electrolyte dissociate into ions, and likewise we get the substance liberated at cathode and we get the substance liberated at anode, right? So that means the weight of substance that we just that gets liberated at cathode or anode, it's just directly proportional to the quantity of electricity which is passed through the electrolyte. So this is the first law. Again I am repeating. It states that the weight of the substance liberated at electrode as a result of electrolysis is directly proportional to the amount of electricity passed through it, right? So that means the weight of the substance which we get after an electrolysis as a result of electrolysis is directly proportional. That means it depends directly. That means its value will increase or decrease on, and it depends on which factor? On the amount of electricity passed through it. That means if the electricity passed is increased, that means the weight of substance, the quantity of the substance or the weight of the substance is obviously going to increase. And likewise, if we decrease the amount of electricity passing through it, the weight of the substance will get decreased. So that means they vary directly. So this I have stated in a mathematical expression. Now I can just write, I know that Q is equal to IT. Right, we know that in physics you have done that current is equal to charge upon time. So that means we can write charge is equal to current into time. So this is what I am substituting in this equation. So I can write W is directly proportional to IT, right, because the Q is equal to IT, so I can just put the value for Q. So we have W is directly proportional to I into T. And as we know, if we wish to use this mathematical expression in form of formula, so that means we need to have an equal to sign. That means we have to just replace this proportionality sign. And this can be replaced by using a constant. And you know that in some cases the constant has the specific name or the values or the units. And in some case there is a constant that is the K, right? But in this case we have a constant which has a specific name as well, and that is the Z. So this is the expression which we get from the first law of electrolysis. Now the question must be coming in your mind that with what name we will be addressing this Z, right? So this is called as electrochemical equivalent. That is the constant, but it has a specific name, that is the electrochemical equivalent. Like if you get the question that state Faraday law of electrolysis, then what you are going to do, first of all you should know that this law gets obeyed only where the electrolysis take place, right? Then how you are going to state that? You will write that this law states that the weight of substance which deposit at electrode after electrolysis is directly proportional to the amount of electricity passed through it. That is this, or we can write this, and Z is electrochemical equivalent, right? After doing this, whether you you can say the question asks you or the question doesn't ask you, you need to define this electrochemical equivalent as well, right? So how you will define it? Suppose if I say that I pass 1 ampere current through an electrolyte and this current pass for time 1 second, right? So if I just put the value here in this equation, so what do I will get? I will get W is equal to Z, right? So if somebody asks you, or if somebody doesn't ask you, you need to write that, right? So how you will define that? Just suppose current to be 1 ampere and the time for the passage is the 1 second, then you will get that W is equal to Z. Then write the definition and what it is going to be, that electrochemical equivalent is equal to the weight of substance. Again I am repeating, electrochemical equivalent is equal to the weight of substance deposited at electrode after electrolysis when, under condition, when 1 ampere current is passed through an electrolyte for 1 second. So this is how you are going to define it. Now, what as a result we get to know, or you can say what is the significance of this law, like what information do we get? So obviously it just gives the the information that amount of substance which we get after an electrolysis, after the result of an electrolysis, right? So it is supposed that when 1 Faraday of electricity, what is 1 Faraday? It is actually equal to the charge of 96500 coulomb. So that means when this much electricity is passed through an electrolyte, it leads to the deposition of the weight of the substance which is equal to the 1 gram equivalent. Right. So that means 1 Faraday, just when 1 Faraday of electricity is passed, that means 96500 coulomb electricity is passed, then how much weight of substance we get at electrode? It is equal to the 1 gram equivalent. Right. So this is how just we are going to relate it. So how we calculate the electrochemical equivalent? It is equal to the Z is equal to the gram equivalent divided by 1 Faraday, that is 96500 coulombs. So this is how, that means by this law we can calculate the value of electrochemical equivalent. Now the question must be coming in your mind that what is this gram equivalent? Like I say, I'll take an example. The mass of silver is 108, you know that, right? So when I pass 96500 coulomb of electricity through this electrolyte which is containing the silver, then how much weight of silver do I get? I get 108 gram equivalent silver I get after it. So this is the gram equivalent weight. So if I wish to calculate this electrochemical equivalent for the silver, that means I will be putting Z is equal to how much gram equivalent? 108 divided by 96500. So this will give the value of electrochemical equivalent. So this is how you are going to just use this first law, as it just decides that what weight of the substance do we get at electrode after electrolysis and on what factor it depends, and how we can calculate the Z for it. Right. Now this is the first law. Now let us see the second law. Second law is so simple. It is as simple, I must say, as it was the first law, right? So what does second law states? This second law states, like suppose, I'll just state an example. Suppose I have AgNO3 solution, right? And I have say CuSO4 solution, right? I have two beakers in which I am carrying out electrolysis of two different solutions. Let it be one be AgNO3 silver nitrate, another be copper sulfate, right? What I am doing, I am passing same quantity of electricity. I am passing same quantity, that means if I am passing Q through AgNO3, so I am passing Q through CuSO4. Q doesn't mean only electricity. Suppose I say X coulomb, then again it is X coulomb. What I am doing is I have taken the different electrolytes, but I am passing the same amount of current through it. Then that means what weight of the substance do I get after electrolysis? That the weight of the substance which I get after electrolysis will be again directly proportional to the equivalent weights. So that means if same amount of electricity is passed through two different electrolytes, I am repeating, if same amount of electricity is passed through two different electrolytes, then the weight of substance deposited at each electrode is directly proportional again to the equivalent weight of that substance. So I can say that weight of silver is directly proportional to the equivalent weight of silver, and weight of copper is equal to equivalent weight of copper. So this is how, that means if same amount of electricity is passed through two different electrolytes which we are concerned with, right? So that means in this we will be calculating in this way, that is the weight of the substance divided by the weight of the other substance is equal to the ratio of the equivalent weight of the first one, which you wrote here, divided by the equivalent of weight of the second one, which you wrote down. So that means if you are given with these terms and you need to find any one of the unknown variable, you can do it by the same formula. So what does second law states? It states that when same amount of electricity is passed through two different electrolytes, then the weight of the substance obtained at each electrode directly depends upon the equivalent weight of the substance. So this is the first and the second law, which is just obeyed by the wherever the electrolysis is taking place, and Faraday is the volunteer who just gave the the standard unit, that is the 1 Faraday. Do not forget this, 1 Faraday is equal to 96500 coulomb. It is its own unit to just indicate the charge which just comprised of 96500 coulomb.